slow. There's no friction, so the block should be free falling. What is the acceleration for free falling object?
-5.8.
Sorry?
-5.8 meters over seconds.
Sorry, say that. Baby, what?
Sorry, do you want like a specific number or just like
Oh, you said 9.8.
Yeah.
Alright, good. And that is the G, gravitational acceleration. Good job. Usually it's 9.8 meters per second squared, but you don't need to memorize that. I'll give you that I'll give you G equals 10 in your test. So that's easier for you. We know that when the slope is vertical, it becomes a free falling object with acceleration G. Theta 90 in the sine give you what? What is sine 90? It's 1. So when angle becomes 90 degrees, A becomes G. It's G going down. It makes sense. Okay. So in your homework, you'll need to use this acceleration to solve for the time it takes for the block to go down here when you release it from rest. And you need to know how to break it down into the components. Okay, yeah, are we good?
So at first the x component of the f(x) equals ma, the ma was 0, but then
Because I made a mistake.
Oh, okay.
The acceleration has x component. So the x component of this equation is ma.
Yeah.
But the y component of the acceleration is 0. It is not accelerating in y direction if we set the coordinate to be tilting like this. Any other question? Alright, so that's about the slope. If you have a slope and you want to pull it with a string, then all you need to fight with is not the entire gravity, but just the tangent component gravity. Is mg sine theta bigger or smaller than mg? It's smaller. Sine theta is always smaller than 1, so you know this component is always shorter than the vector itself. When you have a slope, you can easily move a block upward with smaller force because you only need to fight the tangent component of gravity. If you are pulling a block upward vertically, then the force you are pulling must fight mg directly. But with the slope, the normal force will help you cancel the normal component of gravity, and you only need to fight the tangent component of gravity, which is smaller. Okay? So slope is another way for you to move heavy object. There's of course a cost. If you are moving it vertically upward, the only distance you need to do is going from down here to up here. But with the slope, the hypotenuse is longer than the opposite side. So smaller force requires you to push a longer distance to move it to the same height. That's the price you need to pay by reducing the force you need using a slope. Again, there's something deep about energy conservation, but we'll not learn that right now. Just remember you can use a slope to break gravity into its components and make your life easier when you are moving heavy object. You can even make your life easier with the pulley system. Remember this pulley system? Now if nothing is alright, Alright, so if nothing is having mass, so this plug has a mass, but not a pulleys, okay? And you need to pull it down here. When you pull the string with this pulley system, the string is pulling the pulley twice. So if the gravity on the plug is 20 Newton going down, what is the force you need to apply on the string in order to move it up? Good job, Daisy. You only need 10. Or you only need half of it. Because you pull the string once, and the string goes around the pulley to pull the object twice. You have to pay the price, which if you pull it down 2 meters, it will only go up by 1 meter. Because that's 2 meters of string get distributed to both of them. So there's a price. The amount of, if you decrease your force by half, then you need to move twice the distance. Okay? So you can make your life super easy when you are building a pyramid. You might want to move this block up a height. One way is to use a slope to make your life easier. And you can even design a pulley like this and pull the plug from a field up here. So when you apply the force on the string will pull the plug twice, and you only need to find the component of gravity. Does that make sense? Good. All right, that's all about slope. Any final question about slope? And let's talk about dimension analysis. It's very important. It's going to be in your midterm for sure. For sure, it's going to be there. It's problem 1, so make sure you know how to do it. For everything. Everything you learn in physics can be applied with dimensional analysis, including the spring. So a spring has a natural length when you are not pushing it. When you compress it, we call the length of the spring right now to be L. So the distance that you compress it is the entire distance L naught here minus L. Any question? Now, when you compress the spring will want to push back. This is what we call the spring force, a force from the spring. Should this force from the spring be proportional to the natural length, or the amount of distance you compress it? Who think is proportional to the natural length? Who think is the length of the spring right now? Who think is the compressed distance? Good. So if you do tendency check, and there's anything about the spring force, you know it should be the distance. Both of them should appear. Okay? Now, because it is something like proportional to the compressed length, we add a proportional constant called K, spring constant. So if K appear in the exam and you want to analyze this dimension, you need to memorize this equation for spring. So you can analyze the dimension of spring constant. The dimension must make sense. For force, you need to memorize F equals ma. You need to memorize what are the 3 Newton's laws. Yeah, Daisy?
You had L naught minus L, and
Yes.
then it switched to L minus L naught.
Good job. So let's add a minus sign. Okay.
Okay.
So what you're going to do is to just use this formula to compute the magnitude. You might get a minus sign if you mess up the order of subtraction, but it's fine because if you know you're calculating magnitude, you can just use that as your magnitude and draw the force diagram to know the direction. Okay? Good. Now, F equals ma. So the dimension of force is mass times the dimension of acceleration. You don't know what, if you don't know what is the dimension of acceleration, it's fine. Because you should memorize the definition of acceleration. That's one thing you need to memorize. Acceleration is defined in this class, so that's one thing you should learn in this class. Acceleration is the change of velocity over time. I'm being sloppy because I only want the notation. I only want a dimension. So all I need to know is that it is velocity over time. And now I need to know what is the dimension of velocity. But it's fine because you should memorize the definition of velocity. Velocity is the change of position over a change of time. So its dimension is the position over time. Position is length. So it's length over t minus 1. Okay? So if velocity is length over t, you will get length over t squared if you divide t again. So that's how you can get the dimension of acceleration without memorizing it. What you should memorize is the definition of acceleration and velocity and Newton's second law. Now you know the force should have dimension of mass and acceleration. Acceleration is length over t squared. So you get L and over t squared. And that should be the dimension of spring constant. And the distance subtracting each other just give you something that is a length. So now you're down to just mass, length, and time. You can do the favorite thing, which is canceling stuff. They both have L, so you can cancel L. And you get out the dimension of K is mass over time squared. You need to know how to do that for every of them, including coefficient of static friction, coefficient of kinetic friction,